The other day, a student asked me a question. If we get nuclear power from uranium, why don't we call it uranium power? And as much as I wanted to answer him, I couldn't really do so because we're not studying nuclear stuff and radioactivity in year 8. So I'm going to use this video opportunity to answer your question, Will. So we get the name nuclear power because we get our energy from the nucleus of an atom. So we have this thing, all materials are made out of atoms, and so from those atoms, depending if they break into pieces, we can actually get some energy out of them. So I'm going to show you a couple of things here. First one is, this here is a cartoon. Let me just hold it up here, focus it. So you can clearly see that is a cartoon. Now it's not an accurate representation, but I think for most intents and purposes, this is enough to tell you that it's a ninja and he's carrying a sword. Is that a real ninja? No, well, he'd probably be a lot bigger in real life and maybe not white on a white background. But it's good enough to give you an idea. Same thing over here with atoms. Now, is this a real atom? No, real atoms are much, much smaller, but this is enough to give us a cartoon of what atoms look like. They have these electrons on the outside. They're negatively charged particles that whiz around really, really quickly. And we have this idea that they could occupy shells, but in reality they don't look exactly like this, but it's just good enough. Just like this diagram here is good enough to depict a ninja. This is good enough for most purposes of what an atom is and what it looks like. So in the middle here we got protons and neutrons, and together we call this bit of the atom the nucleus. And that's actually where we get our power from in a nuclear power plant. When a radioactive nucleus, a radioactive isotope of an element, which is let's say you've got a family, you're all share the same surname, you have the same name, so I have a bunch of elements that are same name, same element, but some of those members of that family can be bigger and smaller than others, or slightly heavier and lighter weight than others. Now, some of them are in such a state that they are radioactive, meaning they're not stable, and so they will actually decay, meaning that this thing here will actually start to break down and start emitting all kinds of particles and junk. So the nucleus here actually can break down into smaller bits. And when it does that, we call that nuclear fission. And that fission process, as a byproduct, not only does it make debris, protons, neutrons, and bundles of things like that, it also releases energy. And this energy is usually in the form of heat. And if we can trap that heat, and we can use it to boil water, we can boil water into steam. If we've got steam, we can then push turbines. If we can push turbines, you can then create electricity. And that's how we get our energy from nuclear power plants. So, hope this answers your question, Will, and tune in next time.